fluid water has been tracked down on Mars, and not simply in that frame of mind of a diminutive stream, but as an enormous underground supply that could form a planet-crossing sea. But how did specialists even get on the trail of the red planet's sprinkling mysteries? What does this discovery mean for future Martian pilgrims? And might there potentially be life stowed away in Martian water? Mars has been through a lot over its existence. Although the heavenly body presents itself today as a cold and bone-dry planet, covered in rust, it can think back on a wet and happy past. It's now viewed as sure that, until 3 million years ago, our planetary neighbor still had various streams, lakes, and even some undeniable seas. However, with the loss of the thick atmosphere, the Martian waters also vanished. But where did they go? What happened to the vast fluid water stores that changed Mars into a life-accommodating world? That is precisely the question that has been driving specialists for quite a while. The data gathered during past exploration missions suggests that the ice covers at the Martian poles are basically too small to have stored all the water from the previous seas. The water ice stores that lie dormant under the planet's surface in the mid-latitudes are not sufficient to address this mystery either. Hence, the idea has become established in the cosmic community that the cool wetness left the red planet a long while back. Since Mars has no magnetic field, the high-energy solar wind was able to act on its atmosphere unhindered, consequently stripping a large portion of the Martian water into space. Well, such a hypothesis is intriguing, but what if it's not true? What if the water of the seas was not actually hauled into space at all, but is rather still hidden in the depths of the Martian crust? This is exactly the speculation that sparked the interest of the research team led by Vashon Wright of the University of California in San Diego. They aim to determine the extent to which this speculation matches reality. The specialists investigated the seismological data gathered by the NASA lander InSight on the ground between 2018 and 2022. InSight's measurements had already shown that there is hardly any water in the Martian crust at its surface, but only to a depth of around 300 meters. However, the researchers literally looked deeper into the mystery and considered what the conditions are like 11.5 to 20 kilometers beneath the surface, in the mantle of Mars. The average annual temperature on Mars is a chilly -68 degrees Celsius, but in this secret underground world, it might still be warm enough to allow for the presence of water in a permanently fluid state. Earlier assessments had also shown that the corresponding crustal region could be filled with rock pores that could offer endless pockets for the cool liquid. Eventually, the scientists combined the seismic data with a mathematical model of rock physics, which earthly analysts use, for instance, to identify oil deposits or groundwater reservoirs. The result was significant. The investigations confirmed, on one hand, that the Martian mantle is saturated by various cavities that make up over 15% of the rock. On the other hand, the data showed that the corresponding cavities, fractures, and pores are indeed filled with liquid water. The giant water repository on Mars, the research group stated, is a medium-sized Martian crust of fractured magmatic rock saturated with liquid water. This serves as an excellent explanation for the data collected. For the sake of completeness, however, it should be mentioned that this grand declaration has a small caveat. While it is true that a vast water supply could be hidden deep beneath the Martian surface, this is only accurate if the research results are representative not just for the InSight area but also for the rest of the planet. If so, the red planet could have a groundwater repository in its deep rock pores that even extends across the entire celestial body. This is something we must keep in mind. While Mars was for a long time considered the quintessential planetary example of a dust-dry desert world, the scientists' measurements now show that the mantle contains enough water for a global sea that could flood the entire surface of Mars, covering it 1 to 2 kilometers deep at the same time. However, this poor water supply could also settle the mystery of the water loss. In this scenario, the planet may never have lost its wet face to space through atmospheric outgassing, but rather would have simply moved it. According to this theory, most of the previous Martian oceans might have saturated the depths of the planet's crust, where it has been preserved right up till now as subsurface water. But now that the galactic divining rod has failed, a totally different question emerges. What does the deep water supply mean for future Martian space travelers? After all, it's well known that individuals like Elon Musk not only dream of being the first to bring humans to Mars in the near future but also of one day building permanently inhabited stations on our neighboring planet. So, could future Martians simply scoop water out of the underground repository? Not quite. The truth of the matter is that there is currently no drilling technology capable of reaching those depths. However, just because we can't get our hands on Martian water doesn't mean it's not significant for research on the planet. Michael Manga, a co-author of the study, states that the discovery of water opens a unique window into the climatic past of the red planet. At the same time, this hidden water supply is also considered a place where life may have once existed or might still exist. Could it be the home of extraterrestrial life? There is no doubt that hypothetical Martians would be at home in a truly extreme world, but there is also no question that we know of several terrestrial organisms that thrive in such extreme environments. For instance, there are sponge-like creatures known as extremophiles that were found a few years ago beneath the thick Antarctic ice sheet. These strange organisms live 900 meters beneath the surface and survive in an environment where sunlight and consistent food sources are absent. Moreover, hydrothermal vents at the bottom of the ocean are sometimes even associated with having paved the way for the emergence of life on Earth. However, the inhabitants of the so-called deep biosphere are also resilient survivors. The so-called basement dwellers of the Earth present themselves in the form of microorganisms, viruses, and parasites, which not only thrive in the depths of the seas but also in volcanic rock and even in the kilometer-deep bedrock of our planet. The mainlands, and if the steady haziness and absence of oxygen don't make do to stop earthbound life, why would it be advisable for it to be any unique on Mars? Well, Michael Manga also ponders this, and since water is a central essential for the development of life like that on Earth, he doesn't have any idea why the underground supply of Mars shouldn't likewise be a life-friendly world. Simultaneously, however, Manga accentuates that there is still no proof for the presence of Martian life. Yet, basically, we now know of a spot that would fundamentally permit life on the red planet. Have the hints of Martian life already been found? Well, perhaps yes, and perhaps no, but each thing in turn. The Mars rover, Perseverance, which has been in operation since February 2021, has identified a rock around 1 meter long and 60 centimeters wide at Shava Falls that is currently making enormous headlines. That is because the stone is, as a matter of fact, decorated with some striking signs that could without a doubt demonstrate chemical reactions that microorganisms use as an energy source. Spectrometer assessments have shown that the spots and their environmental elements contain organic carbon compounds. Along with the phosphates and iron that have also been identified, the Martian marks are suggestive of the traces often left behind by microorganisms on Earth. More specifically, such stores on our home planet are often connected with fossil hints of microbial life that have experienced underground iron and phosphate. For example, they are regularly produced when these microorganisms reduce iron oxide. The positive circumstances for rock life to prosper on Mars were most likely created by the water that, according to our discoveries, once flowed over Shava Falls. However, does this ultimately answer what is apparently the most ancient question of mankind, whether Earth is actually the only heavenly body in the universe to have produced life? Well, not exactly. In spite of the fact that the organic molecules on Earth are frequently the aftereffect of microorganisms, they can also be formed in a geochemical abiotic way that doesn't need the association of living things. In light of this, it is also possible that Shava Falls does not show us hints of organisms but only the consequence of volcanic activity. To support this, the specialists highlight a grain of the mineral olivine, which was also tracked down in the rock and is thought of as a regular part of magma. Thus, it happens that the Perseverance rover's discovery right now raises significantly more questions than it answers. Tragically, we will also have to be patient for some time longer before the researchers have interpreted the genuine foundation of the Martian rock. This is basically because the Mars rover has reached the limit of its scientific abilities. The specialists have already captured Shava Falls on camera from each possible perspective and assaulted it with lasers and X-rays to comprehend what truly drove to the arrangement of the strange spots. It's hence essential to bring the rock sample back to Earth and examine it there with high-accuracy analytical instruments. However, when and how the corresponding Mars sample return mission will be completed is now still written in the stars, much like the answer to whether or not Martian microorganisms were truly working at this very moment. You're free to get down to business and click on the subscribe button. Become a part of our community now, and never miss an intriguing video from us again. We'll see you soon.